Hi everyone, we are starting A level 9709 pure mathematics series with the very first topic polynomials. Let us see what the syllabus says, what we have to study in this. We will divide a polynomial of degree not exceeding 4 by a linear or quadratic polynomial and identify the quotient and remainder. We will also see the use of factorial theorem and the remainder theorem. So let us start. A polynomial px is an expression in x of the form ax raised to power n plus bx raised to power n minus 1 plus cx raised to power n minus 2 plus k, where a, b, c till k, these are the constants and n is a non-negative integer. So let us look closely at this definition, that this is an algebraic expression which is denoted by this px. This x, we say that this is a variable. So this is an algebraic expression in a single variable which is satisfying this condition that the degree of the variable, which is n, it should be a non-negative integer. Non-negative integer means that it is a whole number. If you have heard the term whole numbers means all the numbers which start from 0, 1, 2 and all other positive integers, right? So the power of the variable in each term, that must be a whole number, that must not be a negative integer, right? It cannot be minus 1, it cannot be minus 2, it cannot be minus 3. It should start from 0, 1, 2, 3 and 4 and so on, and it cannot be fraction 2. Remember, non-negative integers including 0, we say these are the whole numbers. Okay, so this is a very important condition that differentiate between an algebraic expression and a polynomial, right? This is the basic difference. In any algebraic expression, you can take any value of the power of the variable. It could be negative, it could be fraction, it could be irrational number. But as far as polynomials are concerned, this n, this n, this n minus 1, this n minus 2, all these exponents of the variable in each term, they must satisfy this condition. So let us take some examples. Example number 1 says 3x square plus 2x minus 2, right? If you look at the first term, here the variable is x obviously, and if you look closely at this order, this power of the variable, this is 2, which is a whole number, which is a non-negative integer. So this term is satisfying this condition. Second is 2x. Again, the power of x here is 1, which is a non-negative integer. This term also satisfies. What about this minus 2? Can we say that 2, is there any variable which is attached to this constant? Answer is yes. We can write this as 2 into 1, and this 1 can be written as minus 2 into x raised to power 0, right? So x raised to power 0, this 1, we may introduce a variable x such that x raised to power 0, because x to the power 0 will always be 1, right? So we can introduce any variable to a constant term, right? So if I'm talking about the power of the variable here is, which is 0, which is a non-negative integer, so it is also satisfying the condition, right? So all these three terms are satisfying the condition. That means the given expression can be called as a polynomial, right? And if you find any single term, not all the terms, if you find any single term which is not satisfying this power condition, exponent condition, then you may say that the expression is not a polynomial. Okay, let us look at the second example. The first term is 5x cube. This exponent 3 is satisfying the condition. This is minus root 5x. No matter what is the value of the constant, root 5 is the coefficient of the variable, which is a constant. This root 5 is constant. We do not have to worry about these a, b, c and k. We do not have to worry about this coefficient which is attached to the variable. Okay, it could take any value, but as far as variable is concerned, it should satisfy this condition that it should be a non-negative integer again. So here x raised to power 1, acceptable. Then again we have a constant 8. We can also write this as x raised to power 0. So third term also satisfy the condition. So this second expression can be called as a polynomial. What about the third example? Let us look at closely. This is 3x raised to power 4. All right, minus 9x cube. Again satisfying the condition 3. But what about this root x? As we know that these radicals can be written in terms of power like this. This is 1 upon 2. If it is cube root of x, we can write this as x raised to power 1 upon 3 and so on. If it is fourth root of x, we say it is written like x raised to power 1 upon 4 and so on, right? So this is basically 2 into x raised to power half. Okay, if I again write this whole expression as minus 9x cube plus 3x raised to power half, and this is plus 10, right? So the problem here comes in the third term, which is x raised to power half, and this exponent is not satisfying, does not belongs to integer, right? It is not an integer, whether negative or positive, right? So it is not satisfying this exponent condition, the power condition. So we say that the whole expression is not a polynomial, right? As I said earlier, if you find single term which is not satisfying this condition, the whole expression cannot be regarded as a polynomial. It is just a simple algebraic expression, right? Let us take another example, fourth one. This is x square plus x plus 1 upon x. Okay, it looks like that here the exponent is 2, here the exponent is 1, and here the exponent is 1. So each term is satisfying the condition. So the expression is a polynomial. Answer is no, right? Here it is acceptable, but as far as 1 upon x is concerned, we cannot write the variable in the denominator as far as polynomials are concerned. We will write this as x square plus x raised to power minus 1. Right, we have to bring the variable from the denominator in the numerator by writing negative sign to the exponent. Okay, now here minus 1 is an integer, but it is a negative integer. Remember, it should be a non-negative integer. So it is also not satisfying the condition. So this is not a polynomial. Okay, so I hope the definition of polynomial is clear. We just have to worry about the exponent of the variable, right? If it is satisfying this condition, we say the expression is a polynomial. Okay, now comes what is called the order of polynomial. What order says that you first find out the highest degree term, the term which is having the highest power of the variable. Okay, if you are talking in terms of polynomial, we will look at the variable only. We do not worry about the constant. So if I am saying the highest power of the term, that means we are interested in finding out the power of the variable. It is by default understood. So this is 3x square, this is 1 and this is 0, so highest power is 2. So that will be your order of the polynomial. Here the order is 2. Okay, similarly in the second example, highest term is 5x cube, highest power term is x cube, so here the order is 3. Here order is 4, but this is not a polynomial, right? So first we have to write a polynomial whose degree is 4. So suppose I withdraw this root sign and it is just 2x. Okay, now highest power is 4, so we say this is a polynomial because it is now satisfying the condition, right? Then we choose the order, which is 4. Okay, so order is 4 here, right? It is very simple. You just have to look at the highest power of the variable in the expression. Okay, now depending upon the order of the polynomial, we define types of polynomials. If the order is 0, we say polynomial is constant. If the order is 1, that is linear. If the order is 2, it is quadratic. And if the order is 3, that is cubic, and so on. That we will do in the next video. Thank you for watching. Bye bye. Take care.